Welcome to the deep dive.
Great to be here.
Today, we're heading way back, late Cretaceous period. We're looking into Arrhinoceratops.
Ah, yes, the plant eater with the, well, slightly confusing name.
Exactly. We've got some good scientific papers basically looking at, discovery, the name itself, where it fits in the family tree.
And that name really is the hook, isn't it? Arrhinoceratops. Greek for no nose horn face.
Right. Which sounds straightforward, but it's not.
Not at all. It sort of kicks off this whole story about scientific process and how understanding changes. So yeah, our mission today is to pull out the key info, see where it sits with its relatives, and figure out what the bones actually tell us.
Okay, let's start right at the discovery. How did we find Arrhinoceratops, and crucially, how did it get that name?
Well, the official description was by William Arthur Parkes in 1925.
Okay.
But the main fossil, the holotype that's the key specimen, was actually found a bit earlier, 1923.
Where was that?
It was a University of Toronto trip out at Neil's Ranch, which is along the Red Deer River in Alberta, Canada. They found this partially crushed skull.
A skull. Okay, so that's the basis.
That's the basis. Specimen ROM 796, it used to be ROM 5135. That skull is really the foundation for Arrhinoceratops.
And Parks named it Arrhinoceratops brachiops. We know Arrhinoceratops is no nose-horn face. What about brachiop?
Also Greek, means short-faced.
Short-faced, no nose-horn face. But here's the twist, right? The no nose-horn part.
Yeah, this is the fascinating bit.
Mhm.
Parkes thought it was special because it looked like it didn't have a separate bone making up the nose horn.
Which sounds unique.
Except it isn't. It's actually pretty standard for ceratopsids, the whole family it belongs to. The horn isn't usually a separate piece. It grows out from the nasal bone itself.
So the name is based on a misunderstanding?
Pretty much a misunderstanding of basic ceratopsian anatomy at the time. It really makes you think, doesn't it? First impressions in science can be tricky.
Definitely. And someone later clarified this.
Yes. Helen Tyson did important work later on. You have to remember, Parkes wasn't primarily a dinosaur guy. His background was more in insects, entomology.
Ah, okay.
So he made a few other mistakes, too, in that first paper. Like, he thought the rostrum, the beak bone, touched the nasal bones.
Which it doesn't.
Nope. There are premaxilla bones in between. He also got a bit confused about a part of the cheekbone, the jugal, and thought part of the frill was its own bone, an arch and interparietal. It wasn't.
Wow. Okay, so science marches on. Let's place Arrhinoceratops in time. When was it around?
We're looking at the early Maastrichtian stage. That's late Cretaceous period.
So towards the end of the dinosaur era, but not right at the very end.
Exactly. It lived a few million years before the really famous one, Triceratops.
Interesting. So it wasn't alone. Were there other horned dinosaurs around then?
Oh, absolutely.
No.
It was contemporary with another well-known one, Anchiceratops. They shared the same environment.
Right. Okay, since we mostly know it from the skull, let's dive into that. What did this short-faced dinosaur actually look like based on that skull?
Well, the reconstruction shows this broad neck frill. It's quite squarish, actually. And it has these two big oval openings in it, fenestrae.
Uh-huh.
And really noticeable are these deep grooves on the frill, top and bottom. Probably for blood vessels, arteries.
Yeah.
Suggests a lot of blood flow there, maybe for display or cooling.
Could be. And the edges.
The sides had about 9 bony bunks, osteoderms. And the back edge was kind of wavy, lightly scalloped is the term used.
And wasn't there something unusual about the holotype skull itself? Like damage?
Yes, good point. On the left side, on the squamosal bone, which forms part of the frill side, there's a hole that looks pathological,
Meaning?
meaning it likely happened during the animal's life. Could have been an injury, a wound from a fight or an attack, perhaps. We see these sorts of things sometimes, little windows into their lives.
Gives it some character. What about the horns? The things ceratopsians are famous for.
The brow horns over the eyes were moderately long, nothing too crazy. But the nose horn was different.
How so? Shorter.
Yeah, shorter and blunter than in a lot of its relatives. And despite the name brachiops, short-faced, the snout itself is described as being short, yes, but also quite tall or deep.
Okay, so based on that skull, how big are we talking overall?
Estimates vary a bit, as they often do. You might see popular books say around 6 meters, maybe 20 feet long. But Gregory S. Paul, who's done a lot of work estimating dinosaur sizes, suggested something more like 4.5 meters, about 15 feet, in his 2010 field guide, and maybe weighing around 1.3 tons.
So roughly 2,900 pounds, still a decent size.
Oh yeah, not small, but maybe not quite the giant some popular accounts suggest. It's always based on scaling from the skull and comparing to relatives, so there's some wiggle room.
Right. And we keep coming back to Parks's initial description and the later corrections. It seems really key to the Arrhinoceratops story.
It really is. Tyson's work in the 80s was crucial. The main point, again, is that the thing it was named for, supposedly lacking a separate nose horn bone, isn't special. It's normal for the family.
Shows how science works, I guess. Peer review, new analyses.
Exactly. You need that constant checking and reevaluation as we learn more and get better tools, better comparative anatomy.
Okay, so let's talk phylogeny. Where does Arrhinoceratops fit in the bigger dinosaur picture?
All right, so broadly, it's a member of the Ceratopsia. That's the whole group of horned faces. Herbivores, parrot-like beaks, mostly Cretaceous, North America, and Asia.
Got it. And within that?
Within Ceratopsia, it's in the family Ceratopsae. These are the ones with the really large neck frills like Triceratops.
Okay, Ceratopsidae. And even more specific?
Modern studies consistently place it in the subfamily Chasmosaurinae.
Chasmosaurinae. What distinguishes them, generally?
Generally, Chasmosaurians tend to have longer frills and often more prominent brow horns compared to the other main group, the Centrosaurinae. Think Chasmosaurus, Pentaceratops, Triceratops.
And who are its closest relatives within that group?
Cladistic analyses. These are the studies mapping evolutionary relationships based on shared features. They pretty consistently group Carnoceratops closely with Anchiceratops.
The one it lived alongside.
The very same one. Makes sense, finding them together in the fossil record, too. They seem to be evolutionary cousins.
You mentioned a 2010 study, Sampson and colleagues. Did that show this relationship?
Yes, their cladogram placed Arrhinoceratops and Anchiceratops together. And this group branched off among other chasmosaurines, like Chasmosaurus, Mojoceratops, and importantly, it's seen as branching off earlier than giants like Triceratops and Torosaurus. It helps map its position in that late Cretaceous radiation of horned dinosaurs.
Now, there was another fossil found in Utah that caused some confusion initially, something called Arrhinoceratops, utahensis.
Oh, right. Yeah, that's a good clarifying point. Back in the 1930s, some material was found in Utah. Charles Gilmore named it Arrhinoceratops, utahensis, in 1946.
With a question mark.
Deliberately. He wasn't totally sure it belonged to Arrhinoceratops, and he was right to be cautious.
Because?
Because later on, in the 70s, Douglas Lawson looked at it again and decided it was actually a Torosaurus, so it became Torosaurus utahensis.
So not Arrhinoceratops after all.
Nope. It just shows how things get reassessed. A fossil assigned tentatively to one genus ends up belonging to another. It happens all the time in paleontology.
Okay, so we have a pretty good picture of the animal and its relatives. What about its life? Paleobiology, what did it eat? What was its world like?
Well, being a ceratopsian, definitely an herbivore. Plant eater.
What kind of plants?
Probably not so many flowers back then. They were less common. So likely things like ferns, cycads, conifers, the dominant vegetation of the late Cretaceous forests.
And how did it eat them?
With that classic ceratopsian beak. Sharp, good for snipping off tough vegetation. Then it would process it further back in the mouth with its dental batteries.
And the environment itself, where it lived in Alberta.
The rocks suggest a pretty wet place, a low-lying coastal plain sort of environment. Think forested wetlands.
Climate.
Seems like it was generally warm, but with probably cool winters. Not tropical, but maybe like parts of the U.S. Gulf Coast today, climate-wise, perhaps.
And it wasn't top of the food chain, right?
Definitely not. It would have been on the menu for the big predators of the time. In that place and time, the likely culprit would have been Albertosaurus, a large tyrannosaurid.
Imagine that showdown.
Yeah, the no-nose horn face, which actually had a nose horn facing off against an Albertosaurus. Quite the image.
So let's wrap this up. Arrhinoceratops. We've gone through its discovery by Parks, the whole irony of its name based on a misunderstanding.
That was later corrected, showing science in action.
Right. We've looked at its skull, the square frill, oval holes, short nose horn, moderate brow horns, its size, maybe 15 feet long or so.
And its place in the family tree, a Chasmosaurine ceratopsid, very close relative of Anchiceratops.
And finally, its life as a herbivore in a coastal forest, munching ferns and cycads, while likely keeping an eye out for Albertosaurus.
That sums it up pretty well. Arrhinoceratops, despite the name confusion, really adds another piece to the puzzle of horned dinosaur diversity in the late Cretaceous. And that journey of discovery and correction is a great lesson in itself.
Absolutely. And for you listening, understanding Arrhinoceratops is more than just learning about one dinosaur. It's a window into how we reconstruct ancient worlds from, honestly, pretty limited clues sometimes.
Yeah, fragments of bone, traces in rock.
And it reminds you that what we think we know is always subject to change as new evidence comes to light. Science isn't static.
Which leads to a final thought, maybe. If our understanding of Arrhinoceratops changed so much based on re-examining its anatomy, how many other prehistoric creatures might we currently misunderstand? What other mistakes or incomplete pictures are just waiting in the fossil record for a fresh look or a new discovery to correct them?